There are four properties of logarithms that are useful for converting from linear to decibel and decibel to linear scale, and those are log of x power y is y times log of x, and then log of x times y is going to be log of x plus log of y, then log of x over y is log of x minus log y. And the fourth property that is useful is log of a base b is, let's say log of a base b is c, then a is b raised to the power c. So these four properties are quite useful when converting dB scale from one to the other. And essentially this property is going to be useful that instead of doing multiplications in the linear scale, it is going to be simply additions in decibel scales. Addition and subtraction is a lot more easier than multiplication and division for quickly doing things. And that's why one advantage of switching from linear to decibel scale is most preferred. For example, let's say we know that for such an arrangement, the P out in linear scale is going to be the gain of the amplifier times the P in. This gain is simply nothing but the power gain that has been defined this way in dB. Yeah. So this is the linear relationship between the output power to the input power. For example, let's say in particular case, let's say the input power, just for an example, is 0.2 watts. And let's say the gain of this amplifier is given to be as 40 dB, and this is given in dB scale. And let's say we need to find out what is the output power. So how can we go about doing it? Since this is a multiplication, if we were to do it in linear scale, it's going to be a multiplication, but the same thing in logarithmic scale is going to be P out in dB is the gain in dB plus the P in dB. The product becomes a summation here. So for that, we need to know the gain in dB, which is already given, but the P in has been given as 0.2 watts. So we would want to convert the input power to dB. And P in dB, therefore, is going to be simply 10 times log base 10 of 0.2, and that is going to be roughly minus 7 dB. Minus 7 dB watts, or simply you can write it as minus 7 dB. The gain is 40, so the P out in dB is simply then going to be 40 dB, which is given, plus the minus 7 that we have, and that becomes 33 dB watts. 33 dB watts is the power, output power. And once we need to convert it back to linear, means that this dB watts is going to be 10 log to the base 10 of P out in linear power, right? So how are we going to find out what is this given to be 33 dB watts? Then the P out is simply going to be, we are going to be using this fact over here, is going to be 10 raised to the power 33 upon 10. This upon 10 is because of the 10 over here, and this 10 over here is because of the logarithm which is base 10, and that is approximately 2 kilowatts. So this is going to be the output power in linear scale. So this is going to be around 2 kilowatts. The whole thing is, we could have also done back in the linear scale. If we were to do it in the linear scale, then the gain has to be converted to linear, and that would have been, gain in linear scale is simply 10 raised to the power 40 upon 10, and that would be 10,000 in this case, which is 10 raised to the power 4. So the P out in linear scale is going to be simply gain times P in, which is 10,000 times 0.2 watts, that is, which is the input power, and that is going to be 2000 watts, which is the same as 2 kilowatts. So whether we stick to do things in dB, which is simply an addition, or in linear scale, which is multiplication, the end answer has to be the same.